we're going to write a nuclear equation for the alpha decay of palladium-231. When we are decaying, that means we're breaking down. So we want to figure out what new element we're forming. We know that an alpha particle is basically a helium nucleus. It has a mass of 4. Remember, the mass goes in the upper right-hand corner, and 2 protons, so a charge of 2. Everything has to be balanced. Remember the law of conservation of matter? Everything has to be balanced. So we look at this and we say, what plus 4 gives us 231? So 231 minus 4 is 227. So our new mass is going to be 227. What plus 2 gives us 91, because it's a 91. That would be 89. And then we look at the periodic table. Remember, it is our atomic number, our number of protons, that tells us how many or what element it is. So I go to my periodic table and I find actinium, AC. That has 89 protons. So I come back here, and this got all erased. So it's 231, 91, palladium, decays into my alpha particle, which has a mass of 4, charge of 2. And I could do the helium or I could do the alpha symbol. Either one is acceptable. Plus 231 minus 4 is 227. 91 minus 2 is 89. And that element is actinium. So when it alpha decays, it decays into actinium 227. Now, let's look at this next one. Write a nuclear equation for the beta decay of francium-223. Again, decay, and it's beta this time. So francium-223, 87 francium, decays beta particle. Remember, a beta particle is basically an electron. So the mass is 0 and the charge is a -1. So let's find out what it decays into. What plus 0 equals 223? Well, the mass doesn't change at all. What plus a -1 gives me 87? It's going to have to be up 1 and go 88. 88 plus -1 equals 87. 223 plus 0 gives us 223. Remember, law of conservation of matter, it has to be the same on each side. As long as you remember what the particles are, their mass and charge, you'll have the periodic table and you'll be fine. So let's find what has the atomic mass or the atomic number of 88, and that would be radium, Ra. Now let's look at this next one. Write a nuclear equation for the alpha decay of samarium 149. So we have 149 as our mass. Our mass always goes up top left. The atomic number, the number of protons, bottom left. And since it's decay, we have alpha particle. So that's our 4 and our 2 and our helium nucleus, plus, now we have to determine what our new element is. What plus 4 gives us 149? That would be 145. We could double check. 145 plus 4? Yes, 149. What plus 2 gives us 60? Or what plus 2 gives us 62? That would be 60. 60 plus 2 is 62. Now we look at the periodic table. What has an atomic mass or atomic number of 60? And that would be neodymium. All right. Let's look at some others. Let's see if there is an electron capture. No, there is not an electron capture one. But say, for example, we did want to do an electron capture. Say we are given this problem, and this is completely made up. Write a nuclear equation for the electron capture of and we can do here with our francium, it'll just be the opposite. And that was actinium, 227, and 89. All right, so let's solve this. Instead of just one reactant, you're going to have two reactants because you're going to have your 227 and your 89, your actinium, plus, because you're capturing that electron. Remember, your electron has a negative charge, but no mass. So now you're just finding the one product. 227 plus 0 is 227. 89 plus a negative 1 is 88. Now that you have your new atomic number, you look at the periodic table and you determine that radium is the new isotope that you created. It's a new element. So if you have questions, let me know. We can practice some more, and I'm happy to help. Thanks.